It's only in the last 50 seconds or so that things start to go badly awry for this crew.
At 750 feet, both engines suddenly lose power.
Captain will look across at the engine instrumentation. There's not enough power coming from those engines. They're getting very low. They're getting very low on speed as well.
At 600 feet, both engines fail. The aircraft's speed drops dangerously low. The pilots have less than 30 seconds to react.
Mayday, mayday, mayday!
The crew of British Midland Flight 92 is completing final takeoff preparations for a short flight to Belfast, Northern Ireland. Captain Kevin Hunt flew the plane in from Belfast. First Officer David McClellan takes the controls for the return trip.
Thrust set. Here we go.
As Flight 92 clears the busy airspace around Heathrow, the controller permits the crew to climb to the cruising altitude, 35,000 feet.
Can I have a coffee too, please?
13 minutes into the flight,
Oh.
You smell that?
Is that smoke?
there's a problem with one of the 737's two engines. Captain Hunt takes control, leaving his first officer to work out what's wrong with the plane.
It's a fire, Kevin.
Which one is it?
It's the right one.
The crew tries to stabilize the problem engine by reducing power on that side.
Okay, throttle it back.
Throttle it back.
Seems to be running all right now.
The crew seems to have solved the immediate crisis.
But we still got the smoke.
But want to get back on the ground as fast as possible.
This is Midland 92. We've got an engine fire. We need to divert to East Midlands.
Understood. Cleared for descent to 10,000 feet.
Flight 92 is just 15 minutes from East Midlands Airport. It's closer than returning to Heathrow.
Landing lights.
On.
The pilots will have to make the landing with just one engine.
Flaps 1, please.
To land safely at low speed,
Flaps 1.
the pilots need to set their flaps to increase lift
Power, please.
and call for more power from their one remaining engine. The pilots face a terrifying new danger.
We're losing another engine.
Incredibly, the left engine is now failing. Their plane could soon have no engine power at all. Flight 92 is less than 1,000 feet from the ground. The pilots need to think fast.
Try relighting the other one.
They try to restart the engine they shut down.
It's not. I can't seem to.
It won't start. One engine is dead. The other is in flames.
I have to stretch the glide.
Captain Hunt pulls up the nose of the plane, hoping to stay in the air long enough to reach the airport. But more and more alarms are filling the cockpit.
Damn it!
The stall warning shakes the captain's controls. A deadly sign that they're about to lose their lift. British Midland Flight 92 has slammed into an embankment beside the M1 highway, just half a mile from the airport. 87 of the 126 people on board are alive, but many are injured, including Captain Hunt, who has a broken spine.
Seatbelt, please. Thank you.
Cathay Pacific Flight 780 is cruising at 38,000 feet over the South China Sea. Captain Malcolm Waters and his crew are nearing the end of a 4.5-hour flight from Indonesia to Hong Kong. 165 miles from Hong Kong Airport, the Airbus leaves cruising altitude and begins its descent. And then something goes wrong. The flight computer is alerting the pilots to a problem.
Okay, let's see what we got.
Engine 2 stall.
The plane's monitoring system indicates there's an issue with the right engine, engine number 2. With no explanation for the incident, Captain Waters reduces power on the engine to idle to protect it from damage.
Idle.
The lowest possible power level while still keeping it running. The pilots prepare to land the Airbus with only one engine. Everything is set for an emergency landing. But then, another alert and more vibrations.
Engine 1 stall.
Engine 1 stall confirmed.
Things have gone from bad to worse. The monitoring system indicates they've just lost the other engine, the one they were counting on to get the plane to Hong Kong. The monitoring system tells the pilots to put the malfunctioning engine number 1 into idle. They are a minute from touchdown. Then, another alert.
It's overspeed.
It's an overspeed warning, a signal the aircraft is flying too fast. Captain Waters can't figure it out. They should be slowing down. He rechecks the controls. Then he sees it. Engine number 1, which he throttled back minutes earlier, is still running at 74% power. High thrust, too high to land safely.
Too low, terrain. Too low, terrain.
Their speed is over 100 miles per hour faster than normal. So fast, the flight computer doesn't recognize that the pilots are trying to land. Captain Waters pushes the nose down, forcing the Airbus onto the runway. The Airbus is getting close to the end of the runway. Finally, the aircraft comes to a halt just a short distance from the water's edge. They've used up more than 8,800 feet, over 1.5 miles of runway.
Once the aircraft did stop, there's a look of what the hell just happened.
January 17th, 2008. British Airways Flight 38, a Boeing 777, is approaching Heathrow after an overnight flight from Beijing. It's just 1 minute away from landing. Sculptor Paul Stafford is returning home from a business trip.
It's the end of quite a long, boring flight. We've been flying for just over 11 hours from Beijing. I've been doing work for the university, interviewing postgraduate students. It's all very ordinary.
But it's soon going to be very unordinary. Just 60 seconds from landing, the engines suddenly fail. Captain Ian Hollingworth takes us through the events in a simulator.
They're now on the final stages of the approach, just looking forward to putting it on the airplane on the ground. So they're making sure that all the checks are complete. The captain certainly is making sure that everything's fine. The undercarriage down, final flap selected, the landing check's complete. They've been given landing clearance. It's only in the last 50 seconds or so that things start to go badly awry for this crew.
At 750 feet, both engines suddenly lose power.
Captain will look across at the engine instrumentation. There's not enough power coming from those engines. They're getting very low. They're getting very low on speed as well.
At 600 feet, both engines fail. The aircraft's speed drops dangerously low. The pilots have less than 30 seconds to react.
Captain looks around to see what on earth is going on. The fuel system's in the correct position. The fuel control switch is in the right place. Everything looks normal.
But it's not. The pilot is fast losing any ability to control the plane. It begins to fall through the sky, lifting the nose. he has moments to make a life or death decision.
As the nose begins to rise and the speed begins to drop right off, it becomes apparent that they're not going to be able to make the runway.
10 seconds before landing. Even if they can't make the runway, they have to get over the boundary fence. The captain needs to extend his glide as much as he can. He raises the flaps, streamlining the wings.
The captain brings the flap up to 25. The co-pilot lowers the nose. Mayday, mayday, mayday.
It's only 3 seconds to impact. Captain Burkhill's been so busy, it's his first chance to warn air traffic control.
Pushes forward on the control column to try to recover from an impending stall. Aeroplane crashes.
Flight BA-38 slams down, just short of the runway.
The oxygen masks come down in front of me, all over the plane in front of me. The overhead lockers open, everyone's belongings start to fly out. And the plane's hurtling forward, and I'm hitting my head on the front of the seat, and my foot's hit the back of the seat, and I'm being thrown around, and I have no idea what's going on. And it seems to last maybe 8, 9, 10 seconds, then we shudder to a halt.
Where they land the aeroplane just over the threshold of runway 27 left, away from any of the built-up areas, and they survive. They survive because they did an absolutely brilliant job.
It was thanks to the pilot's quick thinking that he managed to give the plane a critical extra 164 feet of glide path. As emergency services arrive, passengers bail out of the stricken plane. One of the rescuers films the aftermath.
And it's all very calm, it's curious. I walk away from the aeroplane, maybe 100 yards, 120 yards, and I turn around and I see this great big modern aeroplane, this 777, smashed to pieces on the floor.
47 people were injured, but thanks to the crew's fast maneuvering, there were no fatalities.
In the cockpit, the flight crew is relieved, but also concerned that they might be at fault.
Every time, because it's going to come back to us.
The damage to the 747 is extensive. From the outside, the crew realizes that their windshield has been deeply scratched. They see bare metal showing through where the paint has somehow been stripped away. And they still have no idea why any of this happened. The engines were manufactured by Rolls-Royce. Their investigation is led by a former Rolls-Royce engineer, Malcolm Grayburn.
We did do a forensic analysis of the engines. We did record it all in terms of photographic analysis, and also we did a lot of laboratory analysis.
Grayburn discovers the engines were choked with fine dust, pieces of rock and sand. When it was closely studied, they learned that the debris was clearly volcanic ash. Days after their harrowing flight, the passengers and crew learned that the night they were flying, there had been a major eruption of the Mount Galunggung volcano, located just 100 miles southeast of Jakarta. Tom Casadeval is director of the U.S. Geological Survey and has studied the Galunggung volcano.
Indonesia is the world's most volcanically active country. It has more than 130 historically active volcanoes, meaning volcanoes which have erupted in the last several thousand years. Galunggung erupted explosively early in the 1980s. In April, May, June of 1982, the eruptions became increasingly more powerful.
The night Flight 9 flew nearby, the volcano erupted again. As the ash cloud rose more than 49,000 feet into the night, winds pushed it to the southwest, right into the path of British Airways Flight 9. Never before had a volcanic cloud seriously affected an airplane. Could the ash have crippled this flight?
Roger, declare emergency.
Mayday, 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 Speedbird 9. We have lost all 4 engines.
Unlike ash that you might see in a chimney or after a fire in a forest, this is not soft material at all. This is very fine, ground-up particles of solid rock and minerals. This material is very, very abrasive. It's very angular in shape. If you were to see it under a microscope, you would see very sharp angles. And so that's what caused the abrasion.
In addition to sandblasting the windshield and all the leading edges of the plane, could the ash cloud explain all the other strange phenomena the passengers and crew had experienced? The cockpit voice recorder is sent to Washington, but it's designed to tape over itself every 30 minutes. None of what happened in the cockpit during the terrifying plunge from the sky remains.
Without a cockpit voice recorder, we had to reconstruct what the crew said and how they interpreted things and what was going on in the cockpit to the best of our abilities with the other data that was available to us.
A record of the plane's instrument activity during the flight has been captured by the flight data recorder. But again, the team runs into a problem. The flight data recorder experienced unprecedented stress during the dive. There were electrical interruptions too, which caused gaps in the recording. Investigators begin with what they do have. Passengers and crew report that just before the failure of the jet's fourth engine, the plane flew through unexpected turbulence. Had this caused the engine to fail? Satellite weather maps reveal that there was indeed heavy air turbulence over the Pacific. But it wasn't severe enough to cause engine failure. The jet's 4 engines are tested and studied. Even after the horrific dive to the sky, they're found to be in working order. However, given the previous history of problems with Engine 4, it receives particular scrutiny. The wear on a small throttle valve trimmer is measured. It's worn down by only 4 1/1000ths of an inch, but that's enough to restrict the fuel flow to Engine 4. Investigators determined that at 39,000 feet, Engine 4 did indeed deliver weaker than normal thrust. It's known as a hung engine. The aircraft logbook reveals that Engine 4 had been written up on 2 previous occasions just the week before. But after weeks of investigation, the NTSB concludes that the engine didn't need to be replaced. All the repairs were done according to the book. A faulty engine was not the cause of the accident. And even with the loss of 1 engine, the plane shouldn't have been in immediate danger. A 747 is designed to fly on only 3 engines.
Come on, I've got an idea.
With little data from the FDR, NTSB investigator John McAdill comes up with an unusual way to analyze the power coming from Flight 90's engines by analyzing the sound they made. Jet engines contain turbines that make different sounds depending on how quickly they're spinning. When the engine needs more power, the turbine spins faster and the frequency of the sound changes.
You ready to go? Yeah.
The sound of Flight 90's engines should tell McAdill how much power they were generating. And thanks to the unique design of the 737, with its engines mounted close to the cockpit, he already has a recording of the sound he needs. They play back the cockpit voice recorder in a soundproof room.
120.
V1.
Can you take the stick shaker out?
Forward. Forward. Come on.
Lose the crew voices.
Forward. Forward.
The technician eliminates the other sounds in the cockpit one by one, until all that's left is the sound of the engines. The results are dramatic. Investigators now know that the Boeing 737's engines weren't running at full power during takeoff. What they don't know
is why. McAdill has no hard evidence that the sensor was blocked, but he decides to follow a hunch. He uses a piece of tape to simulate the effect of ice blocking the engine sensor. He recreates the actions of the pilots on the day of the flight.
Okay, start her up.
And he records the sound of the engines from inside the cockpit.
Keep throttling up.
He increases power until the engine gauges match the target set by the crew of Flight 90.
Got it.
Blocking the sensors on the test flight should create the same reduction in engine performance as on Flight 90. Both engines should sound identical.
Okay, let's see what we've got.
McAdill compares the sound of his test flight to the engine noise captured during Flight 90's takeoff.
That's a perfect match.
Investigators believe the ice on the wings degraded the plane's performance. When combined with low engine power, though, it was enough to rob the pilots of the lift they needed to climb. The Air Florida disaster was a wake-up call for better flight safety in winter conditions. In the aftermath of this accident, northern airports around the world improved de-icing facilities so that pilots can de-ice near the runway just before takeoff. Powerful technology now clears runways faster, helping airports avoid long delays after a heavy snowfall. Since the Air Florida disaster, pilots and regulators better understand the risk of winter flight.